Okay, in this video we will solve this system using the elimination method. As I work this problem out, I'll be performing calculations, but I will not be showing you those calculations. For example, if I had to do 3 times -7, I'm not going to show you what I do there. I'm just gonna do it. So make sure that you have a calculator, that you're following along, and you can pause this video at any time. So we have the system of 3 equations with 3 variables. 2x plus 3y plus 7z equals 13 is equation 1. 3x plus 2y minus 5z equals -22. And 5x plus 7y minus 3z equals -28. So we're going to use the elimination method. And what we will be doing, so you kind of want to set out a plan ahead of time. And what we'll be doing is we'll be eliminating the x term in equation 2 by using equation 1 and in equation 2. Then we will be eliminating the x term in equation 3 by using equation 1 and equation 3. Notice I said we're going to use equation 1 both times. And notice I said both times we'll be eliminating the x term. That's what you want to do. You want to use one equation twice. Okay, so let's set up equation 1 and equation 2. There's equation 1. There's equation 2. Okay, like I said, ideally the one equation that you would use both times, if you have an x by itself, that's the equation you want to use. Okay, so I don't have that. So what I need to do is I need to multiply both equations by some number. It looks like I want to get -6 and +6. So I'll multiply this equation by -3 and then this equation by 2. So as a result of doing that, I get -6x minus 9y minus 21z equals -39. I distributed the -3 to each term. Now distributing the 2 to each term, 6x plus 4y minus 10z equals -44. Now we add these two equations together. The x terms eliminate. Adding the y column, we get -5y. Adding the z column, we get -31z. And adding the constant column, we get -83. Okay, hold on to that equation. We're going to use that a little bit later. Let's go back up to the original system. So now I want to use 2x plus 3y plus 7z equals 13. And equation 3, 5x plus 7y minus 3z equals -28. Okay, let's set that up to be eliminated. So we'll set up with equation 1, 2x plus 3y plus 7z equals 13. Equation 3, 5x plus 7y minus 3z equals -28. I want to eliminate the x's, so I'm going to have to multiply both equations by a non-zero constant. Looks like I want to get -10 and 10, so I'll multiply our equation 1 by -5 and the other equation by 2. As a result, we get -10x minus 15y minus 35z equals -65. And as a result of the second equation, 10x plus 14y minus 6z equals -56. I will add these two equations together. The x's again cancel. Adding the y column, -1y. Adding the z column, -41z equals, adding the constants, -121. Now I have 2 equations with only 2 variables. I'm going to use those 2 equations now and set up a new system. and eliminate one of those variables. So I'm going to write them down over here. And I'll work on this system right now. Okay, it looks like I can multiply equation 2 here by negative 5. That'll give me a positive 5y to eliminate with the negative 5y. So I'm just going to copy the first equation over because I'm not multiplying it by anything. And now I'll distribute the negative 5 in the second equation. And as a result, I get 5y plus 205z equals 605. Add these together, the y's cancel, and we get 174z equals 522. Solve this for z, and we get z equals 3. Good. Now what we do is we take one of those two equations with two variables, and we substitute z in order to solve for y. So I'm going to use the equation negative 1y minus 41z equals negative 121. This process right now is called back substitution because we are substituting our answers backwards. For example, we just found out that z equals 3. Now I'm going to substitute z into this equation, which contains two variables, in order to solve for y. So I just put 3 in for z. Now I get negative 1y minus 123 equals negative 121. I will add 123 to both sides. I get negative 1y equals 2. Therefore, y equals negative 2 by dividing both sides by negative 1. Now I know what z and y are. So I'm going to take that very first equation that I used both times, which is the 2x plus 3y plus 7z equals 13, and I'll substitute my known value for z and my known value for y in order to solve for x. At this point, you could actually use any of those equations up top. So let's substitute 2x plus 3 times negative 2 plus 7 times 3 equals 13. Remember, y equals negative 2 and z equals 3. So we're just substituting those in to this equation. 2x minus 6 plus 21 equals 13. Grouping like terms, 2x plus 15 equals 13. Subtract 15 from both sides. 2x equals negative 2. Divide both sides by 2. X equals negative 1. Therefore, our solution is the ordered triplet. Now remember, this goes in order x, comma, y, comma, z. Negative 1, comma, negative 2, comma, 3. You can check this by substituting each x, y, and z into each of those three equations and make sure or verify that it's true for each of the three original equations, which it would check.